Hi YouTube viewers, welcome to my YouTube channel. Today let us see about carbon ions. I have already posted videos about reaction intermediates and carbocations. I will give the link in the description box. If anyone need, you can go and refer. Let us go to the topic. Carbon ions are also formed by heterolytic fission as similar to the carbocation. But here the carbon atom will be more electronegative when compared to the atom attached to it. So the carbon takes away the pair of electrons and it becomes an anion, and the other atom attached to it becomes a cation. Hence we define the carbon ion as carbon bearing negative charge. Next let us see about hybridization of carbon ion and its structure. Carbon ion is sp3 hybridized and its structure is pyramidal structure. This structure is proved experimentally, which is similar to the amines. Here a lone pair electron occupies the apex of the tetrahedron, and also the carbon ion, the central carbon atom is surrounded by 8 electrons. So it is an electron rich compound. Now let us see about the stability of a carbon ion. As the carbon ions, I already told, it is an electron rich species and it is an intermediate. It is very reactive, and these carbon ions are attacked by electrophiles. We know that electrophiles are electron deficient reagents. So carbon ion is an electron rich compound. So it is attacked by electrophiles. The carbon ions are stabilized when an electron attracting group is attached to it. So an example for electron attracting group I have given here, a CN group or carbonyl group. If it is present in the carbon ion, it is more stable. Also, the stability of a carbon ion is decreased when an electron releasing group such as halide ion is present in the carbon ion. Like carbocations, carbon ions are also stabilized by resonance. For example, benzyl carbon ion C6H5CH2- is more stable than ethyl carbon ion. I have given here the canonical forms of benzyl carbon ion and its resonance. We are getting so many resonance structure. If we get resonance, more number of resonance structure, then the stability of carbon ion will be more. Here I have given the stability order. First stability carbon ion is benzyl, and then next vinyl, and then phenyl, cyclopropyl, then ethyl, then N-propyl, then isobutyl, and then neopentyl, cyclobutyl, and then cyclopentyl. The stability order when a functional group X is present in the alpha position is NO2, and then RCO is ketone group, and then ester, and then SO2 group, and then CN. CN and amide are equal in order, and then halogens, and then H, and then R. Then we see about how the carbon ions are generated. We already told these carbon ions are formed in many organic reactions as intermediates. So first one is, it is formed by abstraction of a proton in an organic substrate by a base. When we add a base molecule to an organic substrate, the base work is to abstract a proton from the CH bond, and then it results in the formation of carbon ion. Here I have given a first example, that is para-nitromethylbenzene. If we add a base here, it abstracts a proton from the methyl group and it forms a carbon ion. And the next example is cyclopentadiene. If we add base in it, it removes a proton and it forms cyclopentadienyl anion. And next example is triphenyl methane. In this triphenyl methane, if we add soda amide as a base in presence of liquid ammonia, it will form triphenyl carbanion. And next, we can generate the carbanion from alkenes also. When we add a nucleophile to alkenes, it generates a carbanion. I have given one example. And then next we can form carbanion from Grignard reagents, that is alkyl halides. When we add magnesium to alkyl halides in presence of ether, it forms Grignard reagent, and this Grignard reagent acts as a carbanion. Its general formula is RMgX. And then let us see about reactions of carbanions. As we said already, these carbanions are very reactive. They undergo so many reactions like addition reaction, elimination reaction, displacement reaction, rearrangement reaction. First, let us see about addition reaction. As carbanions are very electron-rich compounds, it behaves as a nucleophiles. So, these carbanions adds to the carbonyl groups of aldehydes and ketones. For example, let us see about aldol condensation. Aldol condensation means two acetaldehyde molecule condense to form aldol, that is beta hydroxyaldehyde. Here, first an acetaldehyde molecule reacts with the base to form a carbanion, and this carbanion adds to another acetaldehyde molecule to form aldol. And the next reaction is elimination reaction. When beta phenyl ethyl bromide is treated with a base, it gives a carbanion which slowly undergoes rearrangement to form styrene. Next one is displacement reaction. There are various synthetic applications for beta ketoesters, that is, for example, diethyl malonate and 1,3 diketones. 1,3 diketone, one example is acetyl acetone. These synthetic applications of these compounds are due to the formation of reactive intermediates called carbanions. For example, I have given diethyl malonate here. It reacts with the ethoxide ion to generate a carbanion, which on treatment with alkyl halide gives a monoalkyl derivative. And next one is beta diketone. It also reacts with an ethoxide ion. This ethoxide ion abstracts a proton from the methylene group which is flanked by two ketone groups, and it forms a carbanion. And this carbanion reacts with alkyl halide to form a monoalkylated derivative. Next one is rearrangement reactions. These rearrangement reactions are very less common, but some examples are available. One example is triphenyl ethyl chloride first reacts with sodium to form a carbanion, and this carbanion rearranges, and this carbanion reacts with a proton to form one product and carbon dioxide to form another product. Next one is oxidation of carbanions. When these carbanions are oxidized slowly by air in presence of sodium amalgam, it forms free radicals. For example, triphenyl carbanion reacts with oxygen in presence of sodium amalgam. It forms triphenyl methyl radical. Also, It is oxidized with oxidizing agents like iodine. I have given 2 examples here. These are the examples for formation of dimerization of radical. Thank you for watching my video. If you like this video, please subscribe my channel and share to your friends. Thank you.